In this tutorial, we'll look at how to create instances of each part, how to create node sets at each reference point. The node sets will be used to apply boundary conditions later on. We need to apply an inertial mass to each rigid body, and we'll have to apply damping to each rigid body. But before that, orientate and translate each instance into the correct position. Let's begin by making an instance of the bottom part. So go to Assembly, double click on Instance and choose the part. So we'll start with the bottom part, here it is, and then press OK. We need to orientate the instance so its upper surface is pointing in the positive Z direction. To do that, go to Instance, Rotate, select the instance to rotate, and then we need to define an axis about which to rotate the part. So define 2 points, 0 and 1 in the Y direction, and then we'll rotate it by minus 90 degrees around the axis. Now create instances of the male part, the blank holder, and we'll need 2 blank holders, and finally the blank, and make sure they're all orientated in the right direction. So now we've got all the instances, but you can still see that some of them need to be reorientated, and the relative positions of each of the parts needs to be sorted out. To help you do that, you can use the rotate and the translate tools. You can also use the query tool to find the distances between different parts, and to make it easier to see what's going on, you can hide different parts using this method, or you can show them again using this tool. Be careful not to press delete when you want to show a part again. Ideally, we want to put the center of the blank at the origin and then position the tooling 0.5 millimeter above and below the surface of the blank. That's what I'll do now. It helps to have a calculator and a piece of paper in order to work out how much you need to translate each part. So I've eventually managed to get the blank into the right position. Now I'll rename the blank holders. There'll be a top blank holder and a bottom blank holder, and I'll move each of those into the right position. And finally, we can position the tooling. We'll make sure the tooling is 0.5 millimeter above and below the surface of the blank, and there's going to be a 30 millimeter border between the edge of the tooling and the inner edge of the blank holder. Now we need to make node sets at the reference points on each instance. These will be necessary in order to assign the boundary conditions for the simulation. Let's do this one instance at a time. So we'll hide all but one of the instances. So we're left with the bottom tool. So create a node set. I'll call it RP for reference point, and bottom, we'll choose geometry, continue, and then we'll choose the RP here. Now you can do the same thing for all the other rigid body tools in the simulation. Finally, we need to add an inertial mass and damping to each of the rigid body tools. To do that, we'll assign the mass to each of the geometries we've just created. So go to Engineering Features, Inertias, Point Mass, and then name the mass. So we're going to start with the bottom blank holder, continue, then choose the right set. So if we go here, we've got the bottom blank holder, highlight selection viewpoint so you can see it's been selected, then say OK. And then we'll put an isotropic mass of, let's say, really you should know the mass of the blank holder that you're using, but for the bottom one it's going to remain fixed anyway, so it's not such an issue. So we'll just put 1, and in damping we'll put alpha equals 30. That should do it. The only mass that we really need to be careful with is the top blank holder. And that's because the mass of the top blank holder will push down and apply a pressure on the blank during the forming process. So I'll add a inertial mass to the top blank holder. And we'll give it 0.3 kilos. We can change it later on if we need to. And again, we'll use the same damping. Now you can do the same thing for the punch and the die. By clicking on Sets and Engineering Features, we can see all the node sets and inertial masses that we've assigned to those instances. In the next part of the tutorial, we'll create material behavior and density. We'll define a section and assign that section to the shell elements. We'll create surfaces on all the relevant surfaces in the simulation, and we'll create interactions and interaction properties and boundary conditions.